Okay, so here's the problem at hand here. Okay, we have one of our less esteemed graduates. They're pursuing a degree in physics at some type of school, and they are going to end up trying to collect a beverage. Now, this beverage slides this flask. Okay, so let's kind of draw this situation here. They're going to slide this flask off this counter, and we'll make this flask right here, and they're going to give some initial values here. Okay, so they say that this flask is traveling at a Vx of 1.50 meters per second. We are getting that from right here. Okay, and it's going to sail off the ground, off this counter. We know that it's going to describe a parabola as it goes here, and it's going to strike this at a value, and you need to be cautious here. It's going to be a negative 1.20 meters. Okay, you need to incorporate that negative because it's 1.20 meters below. So the questions we have are: how far away from the bar does the mug hit the floor, and what is the speed and direction at impact? So we know that gravity is negative 9.8 meters per second squared. And guess what? I don't need my mask. I'm the only one in here. So those are our givens. Our unknown for the first one is, what is my delta x? How far did it go? Well, in order to know delta x, I need to first know how long it's been in the air. So I'm going to use first my equation. I'm first going to solve for time and then use that to work back and solve for this. And I know that delta y here equals VIT plus 1/2 AT squared. But since it's launched horizontally, there is no initial velocity in the y direction. So I can simply say delta y equals 1/2 AT squared. With a little bit of daring do, I can rearrange this to say that my time equals the square root of 2 delta y over a. Now I can substitute in time equals the square root of 2, and you may have been dismayed by that negative, but here's where it comes out in the wash: negative 1.20 meters over my negative acceleration of negative 9.8 meters per second squared. And so you end up with a meter divided by meter. Those are going to reduce out. You end up with 1 over second squared, or 1 over 1 over second squared, which ends up being second squared. You take the square root of second squared, you get seconds. So when this comes out in the wash, when I finally solve it, my time here equals 0.49 seconds. Now I can take this value, this is now a new given, and I can plug it into that second equation. I need to figure out what my x component of displacement is. In this case, since there's no acceleration, it's simply going to be velocity times time, and I can substitute in then. Substitute in delta x equals my horizontal velocity of 1.50 meters per second. My time is 0.49 seconds. Seconds in the numerator, seconds in the denominator, I get meters. This ends up being, my flagon will end up traveling a distance of 0.74 meters. Now for the second part, whoops, wrong lab here. For the second part, what we're going to be doing here is now we are going to have two vectors. We want to find out the direction and the speed with which it's going. So we have a Vx and we have a Vy. Now in this case, we already know what Vx is because that was part of the givens. That is 1.50 meters per second. But we need to determine what Vy is, because what we really want to be able to do is figure out this resultant here and figure out this angle theta. Okay, so I do know that I've got an equation to figure out what Vy is. Since there's no initial velocity in the y direction, it is simply acceleration times time, or in this case, it's simply negative 9.8 meters per second squared times my time of 0.49 seconds. And so I'm going to move myself up here. That ends up being, that ends up being a velocity of 4.8 meters per second, and in this case it's in the negative y direction. So I can eliminate that and say that my velocity equals 4.8 meters per second in the negative direction. Now it's all over but the shouting in terms of this concerned, because now we just say a squared plus b squared equals c squared. So 1.50 meters per second squared plus 4.8 meters per second squared is going to equal c squared, or my resultant. And you might be a little bit dismayed that I'm not including the negative. You're going to see why, because we're looking for a speed here, not necessarily a we're just actually looking for the magnitude of the result. But even if we did have a negative here, it would come out when we square it. So this ends up being, the resultant ends up being 5.03 meters per second. So that is going to be the hypotenuse of this triangle. If I want to figure out this angle theta, I can take the inverse tangent of my opposite divided by adjacent. So in this case, my theta equals inverse tangent of 4.8 meters per second over 1.5 meters per second. I find out that this angle theta is going to equal 72.6 degrees. And you notice I was kind of lackadaisical about my positives and negatives on that 4.8 meters per second. That's because I'm just going to determine this in reference to some line. I'm going to call this, when I solve this, 72.6 below the horizontal. Now, you could have just as easily solved this from another means. You could have maybe figured out this angle, which would be 90 minus 72.6 degrees. There's other ways you could do it. You could have, now that you knew this resultant, you could have used the inverse sine function or the inverse cosine function to figure it out. Doesn't matter as long as you get the same result. So if I say 72.6 degrees below the horizontal, that's the same as saying 18.4 degrees from the vertical. Okay, 6 of one, half dozen of the other. So that problem involves a few different things. Not everything you're going to see, but should give you an idea. And this is what I'd ask you to complete for tomorrow, so you're ready to go. Okay, we will talk to you later.